Good morning, gentlefolk. So today is our last day of class. Congratulations, you survived, you made it, you're here. Why is this not charging? Should do it. Except it's not. Oh, that's weird. Sorry, give me just 1 second. For some reason, the laptop charger isn't working. There we go. Okay. Now we just have to get this up without Zoom crashing. Victory. Oh my goodness, look at all this. Okay, so I want to make sure that we talk about all the things on the last day that we need to talk about. Make sure that you guys are comfy with where we are moving into the final, because the final is pretty much all that's left. Today, I am going to send out your take-home exam, exam 4, which is just a little project on systems of equations. Very simple stuff, all the same stuff that we've been doing these last few days. I don't think you'll have a hard time with it. But if you do have questions as you're working it, you can always reach out to me. And I will, just like I would during a regular test that we have in class, I'll do my best to kind of point you in the right direction and make sure that you're comfy working those problems. So let me switch over to the dot cam here, and we can get these first few things out of the way. While I'm waiting for QCam to boot up, did you guys have any questions for me? Anything that you wanted? Sorry, my hair's looking a little crazy today. Anything that you guys wanted to talk about this morning? Any last minute concerns? Anything that you're nervous about moving into the final or getting ready for the end of the semester here? No, I don't have a project associated with the final exam. Yeah, I don't traditionally have one of those either. That's not a coronavirus thing. The final is still on the day it says in our syllabus, and still the same day as it says in East Santa Fe. So that hasn't changed, and we're definitely going to talk about the final today. So let me pull up your syllabus and you can go over those things. Yeah, so for you guys, it's the 28th at 10:30. There is a review packet for the final. Yeah, so let me navigate to these things. It's under student resources. Yeah, so if you go to, actually, here we go. Algebra study questions for the common final. Here we go. So the big review for the final. Now, this semester, the final is a little bit different than it has been in past semesters because it's online. Normally, the final exam is not online. Normally, it's a paper final that we all take on campus at the same time. But at that link that I just pasted into the chat there, you'll find the big review packet for the final. Swap over here to QCam, which is now booted up. And we can get to talking a little bit. So this is, of course, MAC1105, section 5. So exam 4, which is the take home, will be posted to Canvas immediately after class, just after class today. You'll need to download it. And then you can print if you want to. Printing it might make life a little bit easier, or you can write your solutions on a separate sheet. It's up to you. Download, print if desired. Write out solutions. And this pen dying, scan and upload them. By the day of the final. So that's exam 4. Exam 4 is the take home on systems of equations. It's going to appear in Canvas right after class today, and then it is due on the day of the final. You may want to print it. Oh shit, no, this is not that. This is broken. We'll deal with it. You may want to print it because it has a little bit of graphing, but of course you can draw your own coordinate axes on your own separate paper. The final is on 4/28, which is that exactly a week from today? No, it's 4 days from today. Yeah, okay. So it's next Tuesday. And it's a very tight time window. So you have to be working the exam from 10:30 to 12:30. It will be proctored by HonorLock, so you'll get to it the same way you got to exam 3. You're going to go to Canvas. You'll see a thing open up there right at 10:30 that says final exam. You'll click launch proctoring, and then it will walk you through the rest. I saw the request, and yeah, I'm comfortable doing that. I will go ahead and open up all of the homeworks to be played with. So you can work on and review them for the final. Here's the big thing, though. Please read the Canvas announcement I posted about the final. Right, so it's really important that you guys write down thorough solutions, nice, neat, clean solutions to every one of your problems, and upload them to Canvas immediately after the final. I have to be pretty ruthless about this. It's important that I get your written work for the final, and I get it right away after you finish taking the final. I can see in MML when you start the test, when you stop the test, and if there's 2 hours between then and when you upload your work, I'm going to have some questions for you. I don't want to have to deal with that. So if you could, please just make sure that you're writing down solutions to the problems on the final as you take it, and then make sure that you scan and upload those right away as soon as you finish. If I don't have work for a problem, then I'm going to be in a difficult situation. I don't want to do that, but I would be hesitant to give credit for problems that do not have solutions attached to them. I'm not going to be horrible about this, but it is critical that that you read that announcement and that you follow the directions. All right, so please do that. I reviewed the final exam the other day, and I think it had something like 15 multiple choice questions and 15 or 16 free response questions, right around 30 questions. So you have 2 hours to answer about 30 questions. I don't believe there are any problems that don't require you to write anything. So if there's a problem that you just guess on, or if there's a problem that doesn't require any calculation, you can make note of that. You know, just say, you know, if number 15 is a true or false question and you just had a gut feeling about it, you could say, you know, I just had a gut feeling about it, or just guess. You could just write the words guess, anything like that. But I need to be able to see your procedure, especially for the problems that very obviously do require calculation, like the equation solving problems and the simplification factoring problems, those sort of things. I need to have work that I can review to verify that the stuff you put into MML is indeed your own process. So whatever your process is, if your process doesn't involve a lot of writing, that's not the end of the world. But make sure you describe to me your process and that you give me the work that gets you from the question to the answer. So whatever that work is, make sure I have that written down and something I can review for the purpose of academic integrity. Right, it is important. The college confers a degree upon you, and that degree is worth more than a degree from something like Phoenix or one of those for-profit online schools. Precisely the reason that that people trust that the college is honest, you know, and that the students here are honest, and that the grades earned are genuinely earned. So I just want to make sure we can maintain that integrity. Okay. Other questions about the testing situation? So I did slide the exam 3 scores in the gradebook from exam 3 to test 3. The way it works is at the beginning of the semester, when I set up the My Math Lab gradebook, I have a slot in there for each of the 3 tests, or each of the 4 tests and the final. So I took the scores that you earned on the online exam 3, and I moved them into the slot for the usual test 3. And so your grades in MML gradebook should be up to date, modulo any like late work or makeup assignments that I haven't scored yet. I know there are still a few of those things, and I'm going to try to get caught up on those through the weekend. I know I'm behind on that stuff. But if you have a concern about your grade moving into the final, please reach out to me so we can talk and make sure you're in a place you're comfortable. And please do that before the final exam. If you wait until the final exam, things get a little bit harder to wiggle. So we can do stuff before the final. There's stuff that we can do, but after the final, things are pretty much set. So if you're concerned about your grade, if there's something that that you think I haven't scored or something that you think needs to change or anything like that, please talk to me before the final. Okay. So the truth of the matter is, guys, I don't really have a lot of material for us left this semester. We've talked about systems, we've talked about logs, we've talked about exponentials, we've talked about polynomials, we've talked about rational functions and power functions. We've talked about linear functions and rates of change. So I would be happy to, on this last day of lecture, spend some time working whatever sort of problems you guys would like. Are there any problems from the homework that you're stuck on or that you guys would like to play around with a little bit? Oh, actually, hold up real quick. Review session for the final. Yeah, this is something we do need to talk about. So every semester I do a big review session for the college. Usually it's done in P260, the big room in the math building. And usually it's done the Sunday before the exam, but also the exam is not usually on a Wednesday, it's usually on like a Tuesday. So, oh, it is a Tuesday, yeah, okay. So I would be willing to do another one of those big review sessions via Zoom this year. And I just wanted to know when would be good for you guys. So usually I do it the Sunday before the test, that would be this Sunday. And usually it's from like 5 to 7 or something like that. Does anybody have any thoughts or ideas? Is there anybody who would like to attend a big review session that would not be able to make it on Sunday at 5? Or does anybody want the review on a different day? We can do it Monday, the day before the test if you like. We could do it Saturday to give you a little bit more time between the review and the actual test. We could do it at 4 instead of 5. We could do it at 6. So what are we thinking? Hey, come here. Come here, Bubba. Come on in. It's okay. Don't eat the cat food.
Sunday at 5 sounds good.
Okay. No other thoughts about that? There's nobody who wouldn't be able to make it or anything like that? Okay. All right, so I will let the department chair know, and I'll post links to our Canvas announcements, same place you're finding the links to get here. And we will do that big review Sunday at 5. So you can bring questions. Anything that you want to talk about can come from that review packet that I pasted into the chat there, or it can come from the homework, wherever you would like. All right. So that brings us just to our regular class time. Any problems from the homework you guys would like to look at? Anything that's been bothering you or struggling with, or just want to talk about a little bit more? Could also come from the tests or from the projects. Last question on homework 22. One second. Oh, Pearson, don't shit the bed right now. just going to turn off the screen share because it's taxing my computer at the moment. All right. Okay. Oh, we still need, yeah, no, we still need to talk about systems of inequalities. Yeah, of course. Okay. Yeah, we've talked about systems of equations. We haven't done the systems of inequality stuff yet, so we'll do that. So, okay, so I'm going to take a quick look at this problem that Mesa suggested we look at, but I almost forgot. We still have a little topic left, so it does show up in your last homework. So Mesa wanted to see the last problem in homework 22. Let's go ahead and do that. So this is a word problem built around the idea of systems of equations. I'll go ahead and just share the whole screen. All right, so they say a company manufactures canoes and their fixed cost is $18,000. And the cost per canoe is $60. They sell for $240 each. And they want us to find cost function, C of X, find the revenue function, R of X, and determine the break-even. And this is homework 22, question 23. So we'll solve this real quick, and then we're going to talk about systems of inequalities. So the vocabulary here is maybe a little bit weird if you haven't taken an economics class before. But cost is, of course, the money that you need to spend in order to stay in business. So that's the costs of operating the company. The revenue is the amount of money that's coming in, which is different from profit. I want to be clear about that. Revenue is just how much money the company takes in. It's not how much money you get to keep. And then break even is the number of canoes you need to manufacture in order to make sure your revenue and your cost are equal. So it's the amount of productivity you need to have in order to make sure you're not losing money. So it's where your revenue and your cost are equal to one another. First, to come up with this cost function, we need to take our fixed costs. And does that say 118,000 or just 18,000? I thought it was, yeah. Yeah, 18,000. All right. And add to that the variable costs, right? And the idea here is that the variable cost comes from this. This is how much it costs the company to make each canoe. So if they make X canoes and it costs $60 for them to make each one, then it costs them $60X to make X canoes. They always have to pay that fixed cost of $18,000. So think of this as like rent, employee salary, all that shit. And this is how much it costs to make X canoes, because it costs $60 to make each one. We're making X of them. So this is our cost function, our fixed costs plus the cost per canoe times the number of canoes we make. The revenue function works similarly. I sell each canoe for $240. So if I sell X of them, then I get $240X from that. Hamlet. So then to find the break even, this means I need to find when the revenue is equal to the cost. So we're going to set this equal to this. Here. Set this equal to this. God damn it. All right, so I take my revenue, I set it equal to my cost, and that is how I find the break even. That's all, right? This is not especially difficult. I can subtract 60x from both sides. 240 minus 60 is 180. And then I divide both sides by 180, and that is 10. So in order to break even, I need to make sure I sell at least 10 canoes. And then I could, yeah, they want this as an ordered pair. So when I sell 10 canoes, what is my revenue? Well, it's 240 times 10, which is 2,400. So the break-even point is 10, comma, 2,400. Right. This is by far the fastest way to solve this problem. You can interpret this as a systems problem, right? This is the equation of one line, this is the equation of another line, and I'm trying to find where those two lines intersect, where those two lines touch. That will be where r of x is equal to c of x. And it turns out that those two lines touch at this point, 10, comma, 2,400. Make sense? Is this also a dead pen? It's so weird. I swear this pen was alive yesterday. So there is a topic that we need to talk a little bit about. It's the topic for the last little bit of your homework. These are systems of inequalities. A system of inequalities is like a system of equations. It's a collection of inequalities meant to be solved at the same time. So in order to get into these, I think it would be wise if we do a quick review of linear inequalities. Because that's the whole game. We're going to take two linear inequalities and solve them at the same time. We don't end up using anything like substitution or elimination here the same way that we do for systems of equations. These are usually just solved by graphing. So if I wanted to solve the linear inequality y is less than or equal to x plus 2, what this means is that I need to find all the points x comma y which satisfy that relation. Which satisfy y being less than x plus 2. less than or equal to x plus 2. And here's how we do it. We graph the line y equals x plus 2. So I know that that is a line with slope 1 and y-intercept 2. And that splits my plane into two regions. There's the region above the line and the region below the line. And you can test a point from each of those regions. So I'll call this up here region 1, that's above the line, and I'll call this down here region 2, that's below the line. You can think of this two different ways. Here we're saying y is less than or equal to x plus 2, which means my y values, god damn it, demanding-ass animals. Which means that the y value of the points that I'm looking for have to be smaller than x plus 2. Well, here's the line where all the y values are exactly equal to x plus 2. So if I want my y values to be smaller than those, that means I'm looking below the line. That's one way to think of it. Or if you choose to test points, and that is in some senses the safer path, you can test a point from region 1. And you can test a point from region 2. The basic idea is this. If any point in this region solves the inequality, then every point in that region solves the inequality. And if any point in this region doesn't solve the inequality, then no point in that region solves the inequality. So just by testing one point, you can determine whether that region is a part of the solution or not. In region 1, I could test like 2, 2, right? Sorry, negative 2, 2. That's a point that's clearly up there in region 1. And if I plug negative 2 in for x and positive 2 in for y, I get 2 is less than or equal to negative 2 plus 2. In other words, 2 is less than or equal to 0. Is that a true statement? No, right? 2 is bigger than 0, not less than or equal to 0. So region 1 is not a part of the solution. In region 2, I can test, well, 0, 0, the origin is in here. So let's test 0, 0. If I plug y and x for 0 in that inequality, I get 0 is less than or equal to 0 plus 2. In other words, 0 is less than or equal to 2. This is true. So region 2 is a part of the solution. And that's it. We just solved that linear inequality. And The way we would go back and indicate which part is, which region is a part of the solution and which region is not, is by shading usually. So I would shade everything below that line. And we could have known that right away because this says y is less than or equal to x plus 2. I know that that means the y values have to be smaller than the y values here, which means I'm below the line. So you can think of y less than as meaning below and y greater than as meaning above. And then the only subtle point is that if you have a strictly less than, then the points on the line are not a part of the solution. If you have a less than or equal to, then the points on the line are a part of the solution. And the way we demonstrate that in the graph here is that if we have a less than or equal to and the line itself is a part of the solution, like if I take a point that's on this line and plug it in here, I will get a true statement because that point is a point where y is equal to x plus 2. I show that by graphing the line solid. And if this was a strictly less than, then I would graph this using a dotted line to show that that is not a part of the solution. So you can think in terms of above or below, or you can think in terms of testing points. Either way is okay. And that is how you solve a linear inequality. Now, a system of linear inequalities just means doing this twice, right? Your graph here will have 2 lines on it, which means 4 regions. And you can test a point from each region, or you can look at the solution to each inequality one at a time, and then take the intersection of those solutions. So ignore the typed stuff on this page. I'm going to hold this upside down so you can kind of try to follow. So let's look at a system of linear inequalities. Let's say y is greater than or equal to negative x plus 2, and y is strictly less than x minus 1. So what I'm going to do is I'm going to graph the lines y is equal to negative x plus 2 and y is equal to x minus 1. When I graph this second line, I'm going to graph it dotted because of the strict inequality, because it's not less than or equal to, it's just less than. When I graph the first guy, I'm going to graph him with a solid line because that's greater than or equal to. So this guy has a y-intercept of 2 and a slope of negative 1, which means he looks like this. So there's that first inequality. And then the second inequality, x minus 1 there, if I graph that line, that has a y-intercept of negative 1 and a slope of positive 1. So he will look like this. And I'm going to graph him with a dotted line because of the strict inequality, the strictly less than, not less than or equal to. Okay. So this is the line y equals x minus 1. This is the line y equals negative x plus 2. And you see that creates 4 regions. There's 2 ways to get at the solution here. This first inequality, y is greater than or equal to negative x plus 2, that's the one that has to do with this line, is a greater than. So I know that the points that satisfy him are the points that are above that line. This guy says y is less than x minus 1. That means the points that satisfy him, satisfy the inequality associated with this line, are all of the guys below him. So I can shade above the first line and below the second line. And my solution is the stuff that is lying in both solution sets. It's the stuff that's shaded in both ways. So that's all this stuff. We could also get there by testing points. Here's region 1, 2, 3, 4, if you like. If I test a point from region 1, like 0, 0, neither of the inequalities is satisfied, because this says 0 is bigger than or equal to 2. That's definitely not true. And this would say 0 is less than -1. That's also not true. If I test a point from up here, then this first inequality would be satisfied. So say I test 0, 3. 3 is bigger than or equal to 2. That's true. But if I try to plug that into this guy, 3 is less than 1. That's not true. So this region up here satisfies the first inequality, but doesn't satisfy the second. Similarly, down here, if I tested something like 2, -2, I would have like -2 is greater than or equal to 0. That's not true. So the first inequality isn't satisfied. And here I would have -2 is less than or equal to 2 minus 1 is 1. That is true. -2 is less than 1. So the second guy would be satisfied, but the first would not be. And then if I tested a point from over here, like 3, 0, then I would have 0 is greater than or equal to -3 plus 2. That's 0 is greater than or equal to -1. That is true. And here I would have 0 is less than, what did I say? Yeah, 3, 0, right? 0 is less than 3 minus 1, which is 0 is less than 2, which is also true. For my money, the above and below logic works much, much faster. You can get the solution region right away like that. And then you just have to be a little bit careful, making sure that you're drawing your lines dotted if they are coming from a strictly less than or strictly greater than inequality, one that doesn't have the or equals to, and drawing those lines solid if they're coming from a less than or equal to or a greater than or equal to. Okay. So this is solving linear inequalities, systems of linear inequalities. You graph the lines. If you're coming from a strictly less than or a strictly greater than, then you graph the line dotted. If they're coming from a less than or equal to or a greater than or equal to, you graph the line solid. And then you identify the region that solves both inequalities at the same time. So it's the same sort of thinking that we did here, just done twice. And then you take the stuff that is shaded for both of them. Questions on that? There are nonlinear inequalities also. And we've dealt with some of those earlier in the semester, but we dealt with them by solving them graphically, like where is f of x greater than g of x, that sort of thing. I just want to look really quickly at one nonlinear system of inequalities. So this would be a nonlinear system of inequalities, because that first inequality is not linear. It has an x squared in it. But we can attack it the same way. Y is greater than or equal to x squared, so I'm going to start by drawing y equals x squared, which we all know looks like this. And then I also need to draw y equals 2x plus 1. So if this is 1 and this is 2, then 2x plus 1 looks something like this. So this guy right here is y equals x squared. This guy right here is y equals 2x plus 1. And I drew both of them solid, neither of them dashed, because both of those inequalities are greater than or equal to, less than or equal to. They're the or equal to types of inequalities. The first guy says y is greater than or equal to x squared. That means I'm looking for all the points that are above the parabola. So the first inequality has solution set looking like this. Everything that's above the parabola. The second guy has solution set that looks like this, everything below the line. So again, these two curves break the plane up into several regions. You've got 1, 2, 3, 4 regions here. And the region which solves is this one. So it's the same logic that we apply to the system of linear inequalities. It's just that now instead of lines, you have maybe one of them being something a little bit curvier. All right. I know that was a little bit rushed, but that is about what we have time for today. And I don't think you're going to find this homework especially difficult, but make sure that you do finish up homeworks 22, 23, and then that will be it. So I'll have that big review session on Sunday at 5. Look through all the old homeworks. I will go ahead and pop those open on my math lab so you can play with them to study. And I will send out your take-home test in just a little bit. I have one more class immediately after this. They're also getting that same take-home test, so I'll have to talk to them first. But once I finish up with them, I will send out the take-home to both of you guys. The take-home, you're welcome to use your book, your notes, but do not talk to anybody else. Do not use the internet. That's all I ask. If you're stuck on a problem or having a hard time with something, write me a Canvas message, and I'll talk with you about those problems and try to get you through them. But it's important that the work that you submit for those is your own. You can print and write directly on the sheet if you want to, or you can write on your own paper and then scan and upload your solutions. But in any case, I need you to complete the take-home test by the day of the final. So I will accept that all day on the day of the final. It doesn't have to be ready right at the start of the final. That way, if you're having a hard time budgeting your time and you want to come back and finish the take-home after the final, that's okay, I understand. But make sure that you submit the take-home exam for stuff on Canvas on that day, okay, on the 28th by 11:59 p.m. Any last minute questions for me, guys? Okay, then. I'm going to go ahead and end the meeting then. I hope you guys have a lovely rest of your morning. It's been wonderful having you in class. I'm sorry that this semester got so weird, but you guys have all done a really good job working to stay on top of things. Very proud of you. Please hang in there for the next few days. Please follow the directions for the final exam. It's so important. So make sure your honor lock stuff is ready. Read the announcements that I posted and follow those directions very, very carefully so that we don't have things going wrong on the day of the final. If you anticipate something going wrong, if you're worried, reach out to me ahead of time and let's fix that shit before the test. Because the final has to be in this tight time controlled window in order to keep things reasonable. It's critical that we fix any issues before the test. Okay? All right, it's been a lovely semester. Thank you guys so much, and have a nice rest of your day.